Hi, welcome to day 3 of the 100 Days of Common Lisp series. So, in the original, on day 3, the problem is a very simple one. It's about building a conditional sequence uh, represented by this flowchart. So, the user is prompted for some questions, and then based on the answers, the logic flows through this kind of flowchart. So this is a very simple problem if you just use if else. So today in today's session, we'll just look at conditionals in Lisp, specifically if else, but also the other forms like case and cont. Let's start with uh, looking at the actual function which I've written for this problem. We have seen this prompt in earlier videos. It's the exact same structure here. And then I just have a big nested let and if blocks within it. So to start off with, it's very easy. You can look at if as a very normal form. So if you have if and you have a test, so let's say something like this, and then you have your first form or first expression that is executed. If it's easier to represent it like this. There is the first form, and then you have your second form, which is something else. So in this case, we just return a string. It's important to note that everything in Lisp is an expression. In some languages, if is a statement, so it doesn't return anything. But in Lisp, every expression just returns, and you can just use things inside. So for the same example, I could have always added something like this at the very end. So if you see, the indentation is messed up here, but for the moment, what we're doing is just taking the return value of this if else expression and then just using and printing it, right? So you can obviously nest if expressions, so your individual ones can be further expressions. It's not just a single, as you've seen before, you can just use program. So if you want to do this, you can add a program here, and then you can do multiple things here, like on. So this whole program form expression becomes the if positive body, and you can then do your else part if you want, but you can also ignore the else. So if I do this, there is no else form, there is only if positive condition body. And so in this case, both 1 and 2 will be printed. So it's a very beginner confusion to like write something like this, where if you remove the program form and ignore and just have two forms here, you might be confused whether it's actually running all the forms here for the positive condition because there is no else keyword explicitly, but that's not the case. So these two forms, only one of these two forms are going to be executed here, right? So only the first form, because this is true, and if I change the number here, it's no longer true, and then only the second form is going to be executed. Now, it's worth looking for a moment at the Boolean logic here. When something is false, the value that is actually returned is nil. So nil is actually false in Common Lisp parlance. And when things are equal, then what is returned is the symbol true, right? So it's T, which is the symbol for truth. Now, apart from the if else, which I have used here, there are a few other things we can look at. The first thing is an alternative version of a conditional check, which is case. Case is very similar to switch statement that we have in other languages. So, and like it shows here in this example, I can maybe take a different example just to start out with. Let's take this example with numbers. So we have let body here with A as being set to 42, and then in the body we have our case expression. This can actually be indented in a better way. So what you have is very straightforward. You have a case with an argument which is going to be compared, and then you have your matching clauses, right? So it, each clause is again a list where the first argument is being compared with your input, and if that matches, then the second argument would be executed or returned. So in this case, since A is 42, we'll have this statement actually executing. So if I execute this, you will have this answer coming out. So the thing to note here also is that there is an otherwise clause which is equal to the like default or like pass-through clause in other languages. So it is just the symbol otherwise, and that's what will match if none of the other values match. It's not an actual comparison, it's just a keyword used this way. Apart from if and case, we have a third form called cond, like you can see that I've used here. So cond is similar, except we also have conditional checks within the clauses. So instead of comparing a single value with other values, you can do any kind of checks within your individual clauses. So the syntax is very simple. You have cond and then you have your clauses, each clause as a list, and the first argument of that list is your check. So this expression is actually run, and then if truth is returned, then this body of that clause is actually run. And we can have different conditions doing different things, but the first condition that is matched is only that condition is run. So for example, I have an example here where we have cond and we have something very simple. We compare 10 to 10 and then we return 10 if that's the case, and we also do it with 20, but only the first clause is actually executed in that order. And if you notice here, at the end of the cond sequence, you can have true. Directly, you can use true as a condition here. And that's like a catch-all truth condition if you want a default case like we have in other languages. So we have three forms: if, case, and cond, and all are very similar. But there is one more thing to talk about here, and that is the equality function. So in this example, you have seen me use this thing a few times. If to make it more natural, let me do a let body. So let's bind a to 10, right? And in the body, we will do a comparison of a with 10, and that returns true, right? But EQ is not the only equality function in Common Lisp. Actually, Common Lisp has a lot of different equality functions. So what I mean by that is this is also a valid equality function. This is also available. This is also there, right? So there's a bunch of different equality functions, and it can become confusing because they do something similar. You can see the difference now if I try to do something like this, and this will surprisingly return false, right? Versus if I take the same string argument and try with a different function, for example this, right? And this returns true. So this goes back into how each of these functions, what exactly each of these functions do, right? Because they do different things. Like some actually compare the literal values, some compare the underlying pointers or addresses. It can be a bit confusing. If I go to this reference, you can see a summary of all of the different equals and what they do in different scenarios. I also don't fully know exactly what each of them do at the top of my head, but this is a good reference, and you can also find a nice table on what to use for what, right? For example, for strings, always use equal or equal p or string equal and not one of the other forms like eq or equal, right? As opposed to something like symbols or integers or numbers and so on. So now in my code here, you might have seen I have used string equal, right? Which can be again confusing because there are so many functions in Common Lisp and you can't keep track of all of these. So this string equal, this syntax is actually exactly the same as this, right? And also on top of this, if you want to negate a value, so you can easily use the not function. So not of equal 10 would be false, right? So for this case, I could have actually used not here, and that becomes a completely valid expression, nested expression. So we get nil. But like you might have seen in this example here, I have used a different function called string not equal. So it's doing exactly the same thing, but it's just a convenience wrapper to make your life easier if you're if you have to write the longer expressions again and again. So I have used that in this example. If you see, there is a bunch of string not equals, string not equals, string not equals, string equals, and so on. There is one more thing to be said here. If you notice this particular cond expression, it might seem a bit weird when I just talked about case, right? We are in each of these subclauses, we're doing the same thing. We're comparing the input to a color. So instead of doing this complicated thing, I should have used a case, correct? Case of input, and then each of those could just be the colors, right? So for example, here I have written the same example, similar example. Let me indent this properly. So if you set a variable a to high, and then have a case where each of these statements just have the thing that you want to compare to. So what do you expect, right? If I run this right now, I expect to see hello, right? But instead, what happens is you get this, which is the otherwise clause. So this a, which is high, didn't actually match this clause. So, like we mentioned earlier, we have many different equality functions. And the problem here is many of Common Lisp's inbuilt functions actually use equal. And this is documented on this page also here. This is very, very particularly confusing for newcomers. I have spent a lot of time getting confused by this, that many of the functions don't really work for string because they use equal out of the box. So if I go to the REPL, something like equal 10 10 works, and so does something like this, where high is a symbol, but this actually doesn't work. And because of this, you can't really use the inbuilt case in this for string comparison. Now, one way around this is to use this cond. So this works, but if you have a lot of expression clauses, it can become ugly. So there are some alternatives. The one option is to use something called string case, which is from some other libraries, or you can always write a macro to simplify this. That's one of the points of Lisp. The things that the language does not give you, you can create for yourself. You can simplify yourself for your. So we will not do that in today's video, but possibly in a future session, we will look at exactly that, creating our own string case macro, which would work like this case expression, but would work for strings.